Hello, my dear friends. How are you all? You are very welcome in our lecture number 5 of polynomial. So, friends, again, we are going to study very amazing topics in which you will learn a lot of. Okay. So now, without wasting the time, let's start. So now, my dear friends, today we are going to start HCF of given polynomials. Okay, what is? Yes, HCF of given polynomial. Okay, so for two given polynomials, for let's suppose we have two polynomials fx and gx. Okay, we have these two polynomials. For these two given polynomials, let's suppose Rx can be taken as the highest common factor. Rs can be taken as the highest common factors if there is some conditions. Okay, what are these conditions? Let's see that. Okay, so the first condition is Rx is a common factor of fx and gx. First condition should always be Rx should be common factors. Okay, Rx should be common factors of both fx and gx. Okay, so we can write it here as Rx should be common factor. Rx should be what? Common factor of both fx and gx. These are two polynomials. Okay, so my dear friends, I hope you understand these things. So the second condition is that, what is the second condition? Every common factor of fx and gx is also a factor of Rx. Okay, every common factor of fx and gx is also a factor of Rx. Okay, my dear friends, so I hope you understand these things. Now, method of finding HCF of the given polynomial. Now we are learning about how to find the HCF of the polynomials. So first step is that, step 1 is that express each polynomial as the product of powers of irreducible factors. Okay, if we have a factor, if we have f of x, we have a polynomial f of x, we have to express them in the product of irreducible factors, which also requires the numerical factors, okay, to be expressed as the product of the power of primes. First of all, we have to factorize it. Okay, now the second step is that if there is no common factors, then HCF is 1 always. Okay, and if there are common irreducible factors, we find the least exponent of these irreducible factors in the factorized from the given polynomial. Let's suppose we have the factors x plus 2 whole square, and we have a factor x plus 2. So from these two numbers, we just take we will see just only the least power. So what is the least power? This is the least power. So x plus 2 is the common factors. We will write like this. Okay, now what is the step third? So the step third is that raise the common irreducible factors to the smallest or the least exponent found in step 2 and take their product to get the HCF. Okay, so now let's do the example. Yes, so we have the polynomial x square minus 6x plus 5 and x square plus 9x minus 10. So first of all, what will we have to do? We have to the factors of these polynomials. So the factors of polynomials are x square minus x square minus 6x plus 5. So what are the factors? So factors are, you can do it by the factors by splitting method. Okay, yeah. Now I'm writing directly x minus 1 and x minus 5. Okay, this is the factors. And the factors of x square plus 9 minus 10 is equals to x minus 1 x plus 10. Okay, now since the common factors in both of the polynomial is what? Yes, exactly, as you can see that what is the common factors? This x minus 1. So the HCF of these polynomials is what? Yes. So therefore HCF is x minus 1. This is our answer. Okay, now let's move on. Yes, now we have to see what is LCM. LCM of given polynomial. So as you know, what is LCM? LCM is the least common multiples or the lowest common multiples. Okay, it is the product of all the factors. It is the product of all the factors of the polynomials given with their highest exponent respectively. Okay, so now, so this is similar as you will learn in the lecture number 1 in the chapter 1 number 1. Okay, so there is no difference much more. So if we have factors x plus 1, x plus 3, okay, and in another polynomial x plus 1, x plus 5. So if we want the LCM, so what is the LCM? X plus 1, x plus 3 and x plus 5. We multiply the common part as well as the uncommon part. Okay, so now method of finding LCM for the given polynomial. So first of all, we have to express each polynomial as the product of power of irreducible factor. Okay, first of all, what is the step 1? So step 1 is we have to reduce in the factors. Okay, we have to reduce in the factor form which is irreducible. Okay, now second step is that consider all the irreducible factors only once, okay, occurring in the given polynomial. For each of these factors, consider the greatest exponent in the factorized from the given polynomial. So we have to consider what? Yes, so we have to consider the irreducible factors. Irreducible factor, okay, at once. Okay, and for each these factors, consider the greatest exponent. We have to consider the greatest exponent in the factorized from the given polynomials. Now let's come on the step 3rd. So what is the step 3rd? Now raise each irreducible factor to the greatest exponent and multiply them to get the LCM. Now we will see in the direct example. So the first question is, find the LCM of x square minus 6x plus 5 and x square plus 9x minus 10. Okay, my dear friends. So for finding the LCM, first of all we have to do the factors. Okay, we have to yes, we have to find their factors. So what are the factors? So the factors are x square minus 6x plus 5. We can write it as x minus 1, x minus 5 by the factorization method, and the factors of x square plus 9x minus 10 is equal to x minus 1 and x plus 10. Okay, my dear friends. So now, my dear friends, so the LCM is what? LCM is from these factors. We have to take the common parts. First, we have to take the common parts. So what are the common parts? So this is the common part. So here is x minus 1, and write the rest of the uncommon part. What are these? So they are x minus 5 and x plus 10. Okay, my dear friends, so this is the LCM. Okay, yeah, so my dear friends, I hope you understand these things. So now let's move on. Relation between HCF, LCM and product of polynomials. Okay, very easy. So now, if fx and gx are two polynomials, then we have the relation. What type of relation is there? Yeah, if we have fx and gx, we have two polynomials. So there are, what is the relation? So the relation is that HCF of fx, HCF of f of x and g of x multiply by LCM of f of x and g of x. Okay, so what will we have to do? First of all, we have to find the HCF and LCM of f of x and g of x, and then multiply it, which will be equal to plus minus sub in multiplication of f of x multiply g of x. So I hope you get this point. Now let's do the example. So let f of x is equals to x plus 3 whole square, x minus 1, x plus 2 whole cube, and we have gx like this, to be two polynomials. So verify that. We have to verify it. So first of all, what will we have to do? The common factors with the least exponent are, what are the common factors with the least exponent? Let's see. Common factors with least exponent least exponents common factor with least exponents are, first is x plus 3, and second is x minus 1. Okay, and third is x plus 2. Okay, I hope you get this point. Now this is x plus 2 whole square, because here is 3 and here is 2. So what is least? Yeah, 2 is least. So now HCF is what? So the HCF is, this is my HCF one. HCF is x minus 1, x plus 3, x plus 2 whole square. Okay, so all the factors taken only once with the highest exponent are x plus 3 whole square, x minus 1 whole square, x plus 2 whole square. Then it will become the LCM. So our LCM what? LCM is x minus 1 whole square into x plus 2 whole cube into x plus 3 whole square. Okay, so now, so f of x multiplied by g of x is what? This is x plus 3 whole square, x minus 1, x plus 2 whole cube. Now multiply x plus 3 x minus 1 whole square and multiply x plus 2 whole square. Okay, now so the result is x minus 1 whole cube x plus 2 raised to power 5 into x plus 3 raised to power 3. So now what will we get? Yes, x minus 1 whole square. So this is equals to like this, x plus 2 whole cube x plus 3 whole square x minus 1 x plus 2 whole square and x plus 3. Okay, so this is equals to LCM into HCF. If you focus like in previous slide, which is equals to what? This is our HCF and this is our LCM, and here this is our LCM and this is our HCF. So hence proof. So f of x into g of x. This is our verification. Okay, this is our what? This is our verification. I hope you get this point. Now let's go on. So here is very important topic, rational expression. So what is rational expression? Rational expression is an algebraic expression which is of the form of f of x upon g of x. Okay, where fx and gx are polynomial and gx is not equals to 0. Gx should not equals to 0. Okay, so for any rational number of the form p upon q, where p of the form p upon q, where what? P and q belongs to real number and q is not equals to 0. Okay, so p and q are numerator and denominator respectively. Even though p and q are the integer also, p upon q need not to be an integer. Similarly, for any rational expression like this is a rational expression like this, f of x upon g of x is called the f of x is numerator and g of x is the denominator, and fx and gx are the polynomials in which f of x upon g of x need not to be polynomial. It is need not to be polynomial. This is not necessary that the result of f of x upon g of x is polynomial. Okay, I hope you get this point. Let's suppose, for example, so what is the example? Are you understand? Yes. If you have 2x minus 1, okay, x square minus 3x plus 1. This is a rational expression. This is a rational expression. Okay, I hope you get this point. If you solve it, this is not need to be that would be a polynomial or not. This is polynomial and this is polynomial, and after solving that, it is not necessary that it will be a polynomial also. Okay, so now yes, so if we have a knot, what is the knot? Knot is that every polynomial is a rational fraction, is a rational expression, as f of x can be written as every polynomial is a rational expression which can be written as f of x upon 1. Okay, this is our knot number 1. So the second knot is that f of x divided by g of x is not a rational expression if there is a condition, if either numerator means f of x or denominator of g of x or both f of x and g of x are not polynomial. If it is not polynomial, then it is not a rational expression, or if it is not polynomial, then it is also not a polynomial rational expression. If both f of x and g of x are not polynomial, then this is also not a what rational expression. I hope you get this point. So now let's move on. Yes, rational expression in the lowest term. Let fx and gx have integer coefficients. Okay, fx and gx have integer coefficient, and HCF of fx and g of x is 1. Let we have two polynomials, f of x and g of x. Okay, which is having an integer coefficient, and HCF is 1. Okay, then the rational expression f of x upon g of x is said to be in the lowest form, is said to be in the is said to be in the lowest form. So when it is in the lowest form, when the HCF of f of x and g of x is 1, then it is said to be that it is in lowest form. Okay, I hope you get this point. Addition or subtraction of rational expression. So friend, for sum of any two rational expression, let's suppose we have first rational expression is f of x upon g of x, and we have another rational expression h of x and p of x. Okay, if we want this sum, then we can written as f of x upon g of x plus h of x upon p of x. Okay, these two rational expression can be written as like this, and we can written as g of x, we take the LCM, we get like this, and this becomes fx p of x plus h of x g of x. Okay, so if the denominator gx and px are equal, if the denominator gx and p of x is equal, then this is our result. Okay, now if g of x is equals to p of x, so what is our answer? So the answer is that we get f of x plus h of x divided by g of x, and which is equals to, this may be the answer, f of x plus h of x divided by p of x. Okay, I hope you get this point. Now, what is the condition of subtraction? So the condition of subtraction is that it is same. This here we can minus also. Okay, so this is the same, addition and subtraction is same, but just we have to change the sign. Okay, now there is not. What is the not? The not first is that sum or difference of two rational expression is also a rational expression. Okay, I hope you get this point. Now if we are doing fx divided by gx plus minus hx divided by p of x, the sum or difference of rational expression, it will be another rational expression. Okay, rational expression. I hope you get this point. Now, for any rational expression, okay, like we have a rational expression like this, f of x divided by g of x. So minus f of x upon g of x is called the additive inverse. It is the additive inverse. Additive inverse of what? Inverse of f of x upon g of x. Okay. So if we'll, that is f of x divided by g of x plus minus of f of x divided by g of x, we get what? 0. Okay. I hope you get this point. Now, so the first question is, simplify 3x minus 1 upon x plus 2 plus 2x minus 1 upon x minus 1. We have to simplify this. 3x minus 1 upon x plus 2 plus 2x minus 1 upon x minus 1. Okay. So now, my dear friends, first of all, we have to take the LCM. So x plus 2 and x minus 1. This is what? This is the LCM. Now, here is, this will become 3x minus 1 multiply x minus 1. Because if we divide x plus 2 x minus 1 by x plus 2, so x plus 2 will be cancelled. Now we have x minus 1 and we have to multiply this x minus 1 to the 3x minus 1. Okay. Now here, in this case, we have to divide x plus 2 into x minus 1 upon x minus 1. So x minus 1 will be cancelled and we have x plus 2, and this x plus 2 is multiplied by 2x minus 1. Okay, my dear friends. Now we have to solve this expression. So this will become, we have to multiply 3x to x minus 1 minus 1. In this case, this is multiply this by x minus 1 plus, now in this case 2x is multiplied by x plus 2 and minus 1 is multiplied to x plus 2, and we have in the denominator is what? We have x into x minus 1, okay, plus 2 into x minus 1. Okay, my dear friends. So now let's solve this. So this will become 3x square minus 3x, and here is minus x. If we multiply this minus sign to into the bracket, then all these signs will be changed, so it will become plus 1. Here is plus 2x square plus 4x minus x minus 2, and we have in the denominator is x square minus x plus 2x minus 2. Okay, my dear friends. So now we have, if you see that 3x square plus 2x square means we have what? We have 5x square. Okay. Now minus 3x minus x, it is minus 4x. Okay. And this will be 4x minus x is what? 4x minus x is 3x. Okay. So minus 4x and plus 3x. So we get what? Minus x. We get minus x. Okay, my dear friends. And if we talk about the constant part, so the constant parts are plus 1 and minus 2. So we get minus 1. We get what? Minus 1. Now in the denominator, so in the denominator here is x square minus x plus 2. Minus x plus 2 means plus x and minus 2. So this will become x square plus x minus 2. So this is the simplest form. This is what? Yeah, this is the simplest form. So my dear friends, I hope you getting this point. So now let's move on. Yes, multiplication of rational expression. Again, this is very simple. If we have two rational expression, f of x divided by g of x, it can be multiplied by h of x divided by p of x. Then we get same what? G of x into p of x into p of x. Then we get what? F of x in this is in numerator dot means multiply h of x. Okay, so this is our answer. Okay, now again this is an example. Find the product of this and this. Very easy. So x square minus 6x plus 5 divided by x plus 10 multiply x square plus 12x plus 20 divided by x square minus 1. So first of all, we have to the factors of the above polynomial means of numerator polynomial. So it will become x minus 1 x minus 5 divided by x plus 10 multiply x plus 2 multiply x plus 10 divide by x minus 1 x plus 1. Okay, so now from this we can cancel firstly x minus 1 from this x minus 1 and then x plus 10 from x plus 10. So now we get x minus 5 and x plus 2, okay, divided by x plus 1, and the result is x square minus 3x minus 10 divided by x plus 1. Okay, I hope you get this point. So now division of rational expression, again it is very important. So now let's suppose we have two rational expression f of x divided by g of x. This is my rational expression, and the another rational expression is what? H of x divided by p of x. Okay, if we divide f of x divided by g of x divided by h of x divided by p of x, in this case we are turn this sign into the multiplication, then what will happen? Then this expression becomes reciprocate, will be reciprocate. So what is the result? F of x divided by g of x multiply p of x divided by h of x. Okay, so I hope you get this point now. So the question based on the topic is, question number 1 is express x square plus 6x plus 5 upon x square minus 4x plus 3 divided by x square plus 9x plus 20 upon x square minus 3x plus 2. Okay, as a rational expression in its lowest form. Okay, so let's suppose we have x square plus 6x plus 5 divided by x square minus 4x plus 3 divided by x square plus 9x plus 20 divided by x square minus 3x plus 2. Now in this case we have to first of all factorize the equations. Okay, so what are the factors? So the factors of this equation is that x square plus 6x plus 5 having the factors x plus 1 into x plus 5. Now if we talk about the factors of this denominator part, we get x minus 3 into x minus 1 divided by, now the factors of x square plus 9x plus 20 is x plus 4 and x plus 5 divided by the factors of x square minus 3x plus 2 is x minus 2 and x minus 1. Now if we observe that, okay, there is a sign of division. Now we have to change the sign, like x plus 1 into x plus 5 divided by x minus 3 into x minus 1. Now we have to change the sign of division by what? The sign of multiplication, like this. Okay, and for doing this we have to reciprocate the second term. Sorry, we have to reciprocate this term. Okay, so it will become, so the denominator will become numerator and the numerator will become denominator. So we get x minus 2 into x minus 1 divided by x plus 4 into x plus 5, like this. So x minus 2 and x minus 1 is come in the numerator and x plus 4 and x plus 5 is come in the denominator. Okay, my dear friends, now if you observe that, okay, this x plus 5 can be cancelled by this x plus 5 and this x minus 1 can be cancelled by this x minus 1. So we get x plus 1 and x minus 2. Okay, and here is x minus 3 and x plus 4. Okay, my dear friends, now if we solve this, we get what? We get x square minus x minus 2 divided by x square plus x minus 12. So this is our required answer. Okay, my dear friends, so now let's move on. The basic operation on polynomials. So the basic operations on polynomials, what is? In this case, we are doing some sum or difference of two polynomials, multiplication of polynomial. We are not talking about the rational expression. In this case, we are talking about the polynomials. We are talking about the polynomials. Okay, so first case is what? We are doing sum or difference of two polynomial, Okay, so now in this case we are doing directly. Let's suppose we have an expression like this. What if we have p of x is equals to 4x cube? What is happening? 4x cube plus 5x square plus 2x minus 1. Okay, and we have q of x. We have another polynomial which is 3x cube minus 6x square plus 7. So for solving this, we have to do p of x plus q of x. So what will we do? We will do directly adding 4x cube plus 5x square plus 2x minus 1 plus 3x square minus 6x square, this is cube, plus 7. So in this case, we are adding just same degrees number, like x cube is added to this x cube only. Okay, so we get 7x cube and 5x square and minus 6x square. So we get minus x square, means 5 minus 6 minus 1, 2x, and there is no terms of the axiom. So this is same to us of x. Here constant term is minus 1 and plus 7, we get plus 6. So this is our answer. So for the different sum, we can do like this. This is minus, and after this, all these expression, all the sign of this term will be changed, and we will deal according with their sign. Okay.
Okay, yes. Now let's see the difference of polynomials. Okay, so here is, now let's suppose take the similar same example. Here is p of x is 4x cube plus 5x square plus 2x minus 1. Okay, so p of x is 4x cube. Okay, and here is plus 5x square plus 5x square. Okay, and next is plus 2x minus 1 plus 2x minus 1. And the next polynomial g of x is 3x cube minus 6x square plus 7. Okay, so g of x is what? 3x cube minus 6x. Okay, minus 6x square plus 7. Okay, so we have p of x and g of x to polynomial. Now we have to subtract these. So p of x minus g of x. Okay, so here is 4x cube plus 5x square plus 2x minus 1 minus 3x cube minus 6x square plus 7. Okay, so this will become 4x cube plus 5x square plus 2x minus 1. Now if you open this bracket, here you can see that there is a sign of negative. Okay, so all these signs in the bracket will be changed. So this will become minus 3x cube. Okay, here is, this is the sign of negative, so this will become plus 6x square because here is the sign of negative, and this will become minus 7. Now we will solve the like term. So here is 4x cube minus 3x cube, so this will become like 4x cube minus 3x cube, this is x cube. Okay, 5x square plus 6x square. Okay, so we get 11x square. Okay, and here is plus 2x because there is no like terms with the 2x. Okay, and here is minus 1 and minus 7, so we get minus 8. So this is what, this is the answer. So I hope you understand these things, how to solve these types of polynomials. Okay, yes, now let's move on. Now let's see multiplication of monomial.
Monomials, what is monomials? Anyone can tell me what is monomials? Monomials are those polynomials which have only one term. For example, let's suppose we have 4x square y z cube and 3x y square. So if we have to multiply, what we can do it? We can do it 4x square y z cube multiply 3x y square. So in this case, 4 into 3 and x square multiplied by x, y is multiplied by y square, z cube. There is no terms of z cube, so leave it. This is 12. This is x cube. Okay, now the base is same and exponent is different, then the power is add, and this become again 3 and z cube. This is our answer. Okay, so I hope you get this point. Now multiplication of two polynomials. Polynomials means binomial. Two polynomials means binomials. Okay, in that case, if we have two polynomials like this, 2x square, this is 5x plus 6. Okay, this is polynomial, this is not a monomial. Okay, and x minus 1. Okay, so what will we get? We are directly multiplying this, 2x square plus 5x plus 6. Okay, into x minus 1. So in this case, every term of this polynomial is multiply this polynomials. Okay, like this, like 2x square x minus 1 plus 5x x minus 1 plus 6 x minus 1. Okay, so now the result is, if we solve it, then we get 2x cube plus 3x square plus x minus 6. This is our answer. Okay, so I hope you get this point. So now friends, here we are ending a session, and now we will meet in the next lecture. So thank you very much guys for listening me.